Hello, this is Dr. David Kortowitz, and welcome to Solidworks. Today we're going to be exploring some of the additional parameters and settings you can use with the 3D building tools to get the exact geometries that you want in your parts. So let's begin. For the first parameters, we're going to look at extrusion. I have drawn a rectangle here, which is set to the golden ratio, hence the bizarre size on the width. And now we're going to go ahead and try to extrude it. When we hit the extrude button, as you remember, it turns it on its side and allows us to see the extrusion. So the first thing we can do is, if we wanted to, we can click on this arrow and pull, and what it'll do is adjust the distance to be extruded. Now we have that ability in both directions, so you can extrude this way also if you want to, and you can extrude to any length. Now this is probably the most simple parameter set that we can do. I'm going to show you some of the more complicated things we can do now. So if we come over here to the property manager, we can look at, the first thing is from. And what from allows us to do is this allows us to set where the extrude starts. So we can start either on the sketch plane, which is where we started, where we drew our sketch. We can do based on a surface, face, or plane. Right now we don't have any additional surfaces, faces, or planes because we don't have any objects and we don't have any reference geometries. So that said, that one won't work for us right now. Vertex is if we have a point on some sort of sketch or plane or something, and then offset. If we go to offset, we'll get an additional box that says how far do we want to offset it, and we can say 15 or something like that millimeters, and what it'll do is shift it off of the plane. Well, what if I want to go the other direction? So that's what these little arrows, these black and gray arrows up here are. If I just click that, it'll offset in the other direction. Now, these arrows always mean flip direction, and we'll see them quite a bit as we go through SolidWorks. So let's start at the sketch plane because that's what we do have definition for. The next thing we have is direction 1. Direction 1 is going to be in the orientation of the normal. So in the orientation of the positive X, Y, or Z. So right now it's set to blind. What blind means is you go in that direction for that distance, whatever distance we set down here, and you go for that distance regardless if you hit other objects or whatever happens. So blind just will force it. So in this case, it's set to 100 millimeters. It will force a 100 millimeter extrude, even if you don't have the space to do it. If we continue down, we have up to vertex, which allows you to set a point somewhere in space that you will go and extrude until you touch it. Up to surface is actually a really useful one. Up to surface allows you to continue until you interact with another piece of material. So you can do up to surface, and if you have another object, if you click on it, it will wrap itself around that object and make sure that it is in contact, that the end is in contact with it. The next one is offset from surface. It's the same idea except for with a linear offset. So you can say I want it to be 5 millimeters from the surface, and it will do exactly that. Up to body will go until you contact something else. You can select what that something else is, but it'll go up until it touches it. The last one we have here is what we call mid-plane. Mid-plane will shift the extrusion so that it is going through the middle, so the plane is dead center. So wherever we started as our sketch plane, that's going to be dead center in the middle of our volume. This is really useful for symmetric objects that are extruded. And you simply set the length here, and we could say, for example, we want it to go 40, and it will set it automatically to 40. In addition to this, if we go back to blind, you're going to notice that we have a direction 2. What the direction 2 allows us to do is go in the opposite direction. So if we turn off direction 2, we end at the plane. If we turn it back on direction 2, then we could say blind for maybe 100 millimeters. You'll notice it extends the opposite direction. So direction 2 allows you to go both ways and to set proportions. The last parameter we really need to look at here is this one. This bottom thing is called drafting. Drafting is by default shut off, but if you want it turned on, just simply click on the draft button, and now we could set a degrees in which it's drafted. So for the purposes of demonstration, I'm going to change this to something like 30 degrees, and you could see that it thins it equally in all directions at a 30-degree angle. If you want it to go the other way, you just hit draft outward and it will expand as it goes out. Drafting becomes really useful when you want to make parts that can fit into other parts, such as wedges and pins and things like that. Drafting allows you to expand the width. This is a skill that is on the CSWA and is a very useful one to know to save yourself time. So drafting is a very useful setting to know that it's there, although you'll only really use it at certain times and not at others. We're now going to continue looking with Revolve. So I've gone ahead and added a line right here, a construction line right here, which we're going to use as part of our Revolve. So let's start from the beginning, and we're going to use our Revolve base boss. And I'm just going to pick the line over here as my starting point. If I do that, I end up with a disc, a cylinder. And if we look at it, the parameters that we have here is direction 1. We're going blind for 360 degrees. You don't have to go 360 degrees. We can say, 270 or something like that. And what'll happen is we'll get a wedge. We'll get a wedge missing. So we can do that. We also have up to vertex, which allows you to go up to something that's already there. Up to surface is if we have something in the way that we want it to bind with. Offset from surface, again, gives us an offset from that surface so we can go some distance. We also have mid-plane, which puts the plane at dead center. Other things to look at here is what happens if we change our axis of revolution. So what would happen, or at least what would you suspect would happen, if I choose this construction line? I'll give you a second to think about it. Well, if it rotates around this construction line, we have some 20 millimeters of dead space there. What's going to happen is we're going to get a hole in the center with a diameter of 40 millimeters. Let me prove that to you. If I click here, and let me change this to 360 again, and we can then click OK, and I'm going to tip this part up, and now we have a cylinder with a hole in the middle. Now what we can do is we can go ahead and use the sketch. We can use a smart dimension, and if we come onto smart dimension, just use the reference dimension feature, and we can click on, say, this circle here, and we'll see that it has a diameter of 40 millimeters. Now what reference dimension does is that allows you to add a dimension to a three-dimensional object that isn't necessarily fixed. It's going to give you just a reading of what that current dimension is and not affect the object. Now if you want to change something about it, you can always double click on the object and it's going to show you all the dimensions here. And simply, if I went here instead of 100, change this to say 200, you just click on it, 200, enter, and once you OK the dimension, it is going to ask you to rebuild. You have this little traffic light, you click rebuild, and now it's 200 tall. So you can adjust things without actually editing the object or the sketch. So now let's take a look at our swept base boss. I've gone ahead and just added a spline here with a relatively gentle curvature. It's important to note that if the curvature is too sharp, you won't be able to perform your sweep because the shape of the profile will actually collapse on itself. So make sure that your path actually makes sense given the properties of what you're going to be sweeping. So if we click on swept base boss, the first thing it wants, the first parameter we have is we have what's called a sketch profile or circular profile. If you choose a circular profile, you're going to get basically a circle which you can set the radius of. So right now it's 10 millimeters. If I go ahead and select my path, it's just going to put a 10 millimeter tube around my path, and that will be it. We can go up to say 50 or something like that just to show you it exaggerated a little bit. But that's what that's for. But we're going to use a sketch profile, and we're going to use that rectangle that we've been using so far. And if I click on it, you can see it sort of expands. Now, with a swept base boss, we don't have all that many options. You have guide curves, which allow you to define the outside. I have options, which allow us to say follow path or keep your constant normal. If you keep your constant normal, it's going to keep everything oriented the same and not necessarily the same with the path. But we're going to follow the path in this case. We're going to say that we can set our twist. We're not going to set twist necessarily. We could do tangent to adjacent faces if we really want to. Since there are no adjacent faces, it's going to say no. We want to merge tangent faces. What that'll do is if you're going between two objects, it'll actually weld everything together into a single object. Start and end tangency allows you to set exactly how the behavior of the contour will be within the line. And then we have availability of curvature display that allows you to see a mesh preview, which just shows you lines. We have the ability to put zebra stripes on it, which helps you sort of see the curvature. And we have curvature combs. These can all be useful in visualizing how your contour is going to work, although more often than not, the easiest thing to do is just click the OK button and take a look at the shape and make sure it makes sense. Now, we can do different things if we want to. For example, let's go ahead and edit sketch 1. And what we're going to do is I'm going to hit normal 2, and I'm going to add a offset into our contour. So I'm going to say, okay, offset entities, and I'm going to offset the entire rectangle, and I'm going to offset it by, say, 30 millimeters, and we're going to do reverse. And you select the chain, and 30 is a little much, so let's do maybe 10. And now if I click OK, it's going to put an inner border. Now what that means, if you notice that part of it's dark gray and part of it's light gray, this dark gray here is not going to get extruded when we do, or is not going to get swept when we do our swept base boss. The lighter gray area will. So if we exit the sketch now, what you'll see is we actually have an open end here, and this thing is hollow. This could be really useful if you're designing things such as ductwork or places where air blows through or water blows through or something like that. So this actually is a very handy strategy. Now, another tool that we have available to us is the shell tool, which we can use to do a very similar thing. Let me show you really quickly how the shell tool works. So if we edit this sketch again and we're going to revert it back, I'm just going to delete all these lines. You just simply click on them and hit the delete button on your keyboard. And that'll get rid of all these lines, and we can exit out. And what we have now is we're back to having our closed contour. Now the shelling tool is up here on the top, and we can choose the shelling tool. And then we can click on, say, the face of this, and we can tell it how far we want to shell. So before we had a 10 millimeter boundary, that works for me. If I click OK now, it's going to cut a 10 millimeter boundary into our object. Now it's not necessarily liking this because it's saying that one of the faces is held in our contour. We can do shell outward and that'll work fine. Now, if we look very closely, what we'll notice is it only shelled to a point. So it's hollow, it's 10 millimeter walls. Now, if we come to this end, we notice that it's not open. And part of that is because the shell is going to leave a 10 millimeter wall, because that's what we told it to, all the way through. And this end, it doesn't know is an exit. So there's a few different ways you can fix that, but that's for a later lesson. So we've gone over all the parameters and settings for the different base boss or boss base type objects and methods in this lecture. So we've gone over all of the different parameters which you can set when you're developing a 3D object from 2D sketches. So today we've gone over all of the parts. So today we've gone over all of the parameters and configurations you can set when you're going from a 2D object to a 3D object. These parameters are very useful and are something that you're going to need to know how to set when you're modeling three-dimensional objects. I'd like to thank you for your time. See you next time.